Sudhanshu, we are live.
Yeah, Chris.
Yeah, we'll wait for some time so that
Send
everybody
me a
joins.
link.
Okay.
I think I don't have a link actually, so let me check.
I've sent you the link.
Okay, yeah, sure. Okay, I got it. Yeah.
Okay, now people are joining.
We'll wait for some time so that everybody. Yeah, sure.
Okay, hello everyone. Hello, guys. So today's the main agenda is basically to cover encoder decoders, attention model, transformers, but probably we will be dividing this series into two parts. Today, 2 hours is fine, right, Sudhanshu?
2 hour, yeah, one and a half hour today, and then like one and a half hour like tomorrow. No, not tomorrow. Day
No, on
after,
Wednesday.
I think on Wednesday,
Wednesday.
because people will not be able to like sit for that long, right? Maybe. So I think we should give them a rest, and like we can cover these things.
So right now it is 8:30. So 1.5 hour we will take. Probably till 10 o'clock we will.
Yes, yeah.
Yeah.
So today we'll try to clarify the fundamentals, and so that they will be able to like start ahead with these things. And again, so like day after tomorrow, so we can try to discuss some of the advanced topic, some of the advanced research paper.
But again, the main agenda is to completely cover encoder, decoder, attention models, transformers, but theoretical part.
Yeah.
Practical part in the future, I'll be uploading it, so you don't have to worry. This will be a part of deep learning playlist, guys. So I think we have more than 162. But before joining, please do hit a like for Sudhanshu's session today. And I think you'll love his session because I've seen a lot of his sessions, so probably you'll also love it. Okay, Sudhanshu, to you, you can share your screen and you can start the session.
Yeah, sure. Yeah.
Yep.
Just wait for a moment. So like
Sure.
4 to 5 minutes.
Sure. So we'll wait for 2 minutes till he joins. सर कल से कम्युनिटी क्लासेस स्टार्ट. हाँ जी, उसका भी कल अनाउंसमेंट अभी एंड में अनाउंसमेंट कर देंगे. ठीक है, we'll announce that soon. When will you start?
Okay, Chris. So I think we can start. Yeah.
Yeah. So you can share your screen and you can start.
Yeah, sure.
Are you able to share your screen, Sudhanshu?
Yeah, Chris.
Okay.
Can you please give me the access for this one?
Okay, just a second.
Just click on share screen option and then multi-participant.
Where that option will be?
Like in a share screen option, right? So you will be able to see like a one tick mark, and there you have to click
multiple participants share simultaneously. Okay, done.
Yeah, now it's cool.
Okay, you are doing in your workstation, huh? Amazing.
Yes, yeah. So I think I'm audible, right? Clearly.
Yeah, you're audible. You're
Okay.
audible, sir.
Okay. So fine, guys. Hello, everyone. So my name is Dhanshu Kumar, and today I will be talking about basic of I can say how this language translation works, and basic of encoder decoder. And in the same sequence, so we are going to talk about many more things. So first of all, I will try to give you a brief introduction about a problem statement, right? So what kind of a problem that we will be able to solve if we are trying to use this encoder decoder, or maybe a attention based model, maybe a transformer based model, and then probably we can try to get into a BERT or any kind of a transfer learning based model, right? So first of all, let's try to understand a problem. So what is the problem that people were facing, and why we used to talk about RNN LSTM, RNN LSTM, or RNN GRU, right? And then we will try to understand that, okay, so what is encoder, what is decoder, right? What is an encoder with a simple RNN, or I can say a basic RNN cell, or what is a kind of an encoder that I will be able to build with the help of bidirectional RNN, or I can say in a deep RNN, right? So these are the things that we are going to understand, and then we'll be able to understand that what is a transformers, right? So we'll try to understand what is transformers, because unless and until you will not be able to understand, so what is RNN, what is LSTM, what is encoder, what is decoder, so it will be difficult for you to understand a transformer. Transformer is not that tough, but in terms of implementation, in terms of architecture. But yes, these are the basic things: encoder, decoder, RNN, LSTM, GRU, and based on that you will be able to understand a transformers. Once you will be able to understand a transformers, then we are going to talk about one research paper published in 2018, that is called as "Attention is All That You Need." If you are able to understand this particular paper, right? So let me just show you these things. There is a paper called as "Attention." So this is the research paper that we are going to discuss, we are going to talk about. And this was a research paper which has been published by Google around in 2017 end or 2018, right? So this was a breakthrough that people have made, which has revolutionized the entire NLP, right? So whatever kind of a model that you will be able to find out, whether I'm talking about a BERT, or maybe a Albert, or maybe a Electra, maybe a GPT-1, GPT-2, GPT-3, right? Or maybe like a transformer excel. So all of these models has been derived, has been built on top of this research paper itself, which is called as "Attention is All That You Need." And here you will be able to find out one of the complex, one of the kind of a black box kind of a diagram, right? So once you will be able to understand this diagram, right? So what is a multi-headed attention, what is a feed forward network in this particular place, how these things are placed, what is the number of layer of these networks, then you will be able to understand BERT and all of those things which people have published after this paper in an easiest possible way. So first of all, your base must be very much clear, right? Then only you will be able to understand each and everything. So fine, let's try to
Danshu,
start with a problem statement.
so
Yeah,
Danshu,
please.
just you can you zoom in the screen once?
Yes, yeah.
Just
I
zoom in.
already zoomed in the screen, so don't worry. So I'll zoom in the screen.
Yeah,
Yeah.
sure. Okay.
Let me check how it looks like. Yeah, now it's looking fine, I think.
Yeah. Now it
Okay,
is fine. Yeah.
fine. Okay, so fine, guys. So first of all, what we'll try to do is, so first of all, before discussing about the architecture, right? Because unless and until you are not facing an issue, you are not facing some kind of problem, so you are not going to do any kind of a innovation, right? So once you will face some kind of a issue, some kind of a problem, then you will look for some kind of a innovation, so that you will be able to solve your current or existing problem, right? So this is a kind, there are variety of the problem that people was facing, right? So if I'll try to name one or two problem, so the first problem which comes in my mind is language translation, right? So we have seen that there is a Google translator, right? So once you will try to say something, or once you will try to type something, right, in a Google translator, so it will try to convert any X language to Y language, maybe from English to Hindi, or maybe Hindi to some other language, or English to French, English to German, or in some other languages, right? It will be able to transfer in an easiest possible way. That is particularly fine. So language translation is one of the issue that people was facing. So they were not able to translate this entire language, right, in their respective, or in their like in their like a respective different languages, or maybe Hindi to English or English to Hindi, right? Because whenever we talk about a language, right? So suppose if I'm trying to say some word, or suppose if I'm trying to like iterate some kind of a sentence, right? That like my name is Anshu Kumar, right? So again, if I'll have to say a same thing in English, right, in Hindi, right? So I'll have to say like mera naam Sudhanshu Kumar hai, right? Now the sequence of the word, right? So it's not a kind of a one-to-one translation that you will be able to do. My name is Sudhanshu Kumar, so it's not a one-to-one translation. Or let's suppose if I'm talking about a data science, right? So data science or AI is an area where you will be able to use a machine learning, deep learning, NLP, computer vision, or like a advanced NLP, reinforcement learning, and you can solve many real-time problems. Now if you have to translate this line into some other sentences, into some other languages, right? So for sure, this translation is not just a one-to-one translation. You will start with, okay, so data science. So you can't translate this data science exactly in the same way, like in a one-to-one way, right? So here what you have to do, so here first of all you will have to understand the sentences, you will have to understand a context, and then on top of that, so you have to generate a new sentence, you have to generate a new word which must be arranged in such a way that it can make some kind of a sense, it will be able to give you some kind of a meaning, right? So in this way, to solve this kind of problem, right? So people was facing a lots and lots of different kind of issues, and they were not able to translate any of these kind of a situation, or they were not able to transform this kind of a sentences in any other sentences. That was the first problem. Second problem, if I'll talk about, right, a question answering system. So let's suppose nowadays, so almost every website, right, every website or like every service provider, so they used to integrate a chatbot, right? So now chatbot again. So I can ask one question. So suppose if I'm trying to look for some kind of a like some kind of a material, or suppose if I'm looking for some kind of a maybe like some kind of a maybe like some kind of subject or something, right? So I can ask a question that, okay, fine. So I'm looking for a mouse, right? Now a meaning of mouse is different if I'll try to understand a meaning of mouse in English, right? And if I'll try to talk about this mouse in terms of a like a hardware, right? So meaning of this mouse is different, both the places. Suppose if I'm trying to like chat with my finance team, right? And if I'm saying that, okay, fine, so bull is going high, right? So here, if I'll try to find out a meaning of a bull, right? So I think we all know a meaning of a bull. It's basically an animal, right? According to dictionary. But if I'm trying to say that bull is going high to my finance team, right? If I'll try to talk about these particular things, this particular context to my finance team. So basically a meaning of bull is not an animal. Meaning of bull is basically a share market or a stock market. So here you will have to understand a context. Unless and until you will not be able to understand a context, right? And this context will not be mentioned inside the sentence, right? So you will have to understand this context based on the sentence or based on the conversation which is going on. And that's again an issue, right? So again, as a human being, our brain is trained to do that. But what about machine? How they will be able to understand it, right? Again, if I'll talk about another kind of a context, let's suppose I have to like find out a sentiment of some of the words, or sentiment of maybe some of the sentences, right? For sure. So unless and until I'm not able to understand the entire context, right, I will not be able to like find out the exact sentiments. Maybe suppose if I'm trying to give like a review to a Swiggy, right? So I can say that, okay, fine. So like delivery was good, but food taste was not good, right? In that case, system will be confused whether we are talking about a negative sentence or we are talking about a positive sentence, or positive sentiments or a negative sentiments, right? Again, there will be an issue, right? So these are the kind of a issue, different kind of a issue that people were trying to face, and keeping these things in a mind, so they have started designing a different kind of a neural network. It doesn't mean that we didn't have a neural network. We had a neural network. Even before that, we had a neural network which can try to solve a complex problem, which will be able to understand our relations. That is completely fine. But unless and until we are not able to get an architecture which can work for a certain set of a problem statement, I can say that I will be on a point zero. I will be on a point zero and I will not be able to provide any kind of a solution. And keeping these things in our mind, right? So keeping these things in our mind, so people have started designing a different kind of a network. And the first kind of a network that people have designed was LSTM, long short-term memory. But before LSTM, people have done a lots of research in CNN, convolution neural network, and people have released a different kind of architecture as well, like a LeNet, like a LXNet, which is 16, which is 19, a ResNet 50, ResNet 32, 34, sorry, ResNet 101, ResNet 150, InceptionNet, GoogleNet, DarkNet. So these are the CNN based network. Now, why it will not be able to solve? These are also neural network basically, but why it will not be able to solve the problem statement which I was talking about? It will not be able to solve a problem statement because it will try to train its weight. That is fine based on the input data that we are trying to give to the model. That is completely fine. But at the same point of a time, if you have worked in CNN, you must have seen that from one end, right, we try to give an input, that is fine, and then there will be a weights. So we try to get an output, then we try to do a backward propagation, and then we try to train a weight based on the loss that we have received and the optimizer that we are going to use, right? That is fine. Once I will be able, so every time in every iteration, so we are trying to send a data, right, from our input side to output side, and in a backward propagation, so we are trying to train the weights, we are trying to understand the relations based on the loss, and we are trying to reduce a loss over there, right? Doesn't matter what kind of a loss that we are talking about, whether it's a L1 loss, L2 loss, hinge loss, Huber loss, cross entropy loss, right? So there are different kind of a loss function which has been used with the respective networks. Now, so in this situation, what happens is, so we are trying to send a data into a neural network from one end, and we are able to get an output from another end. That is completely fine. But in this case, right, in this case, what is a lag? A lag over here is that you are trying to just send a data into a forward direction, and then in a backward direction, you are just trying to train the weights, and in this way it will not be able to remember that what I have sent last time, right? It will not be able to remember that what kind of input data that we have given last time. And that was an issue with the CNN. If you will try to utilize CNN to solve these problems, CNNs are good to understand an image. CNNs are good to interpret our videos. That is completely fine for video analytics, for image analytics. You will be, for object detection, for object tracking, for object segmentation, you will be able to use a variety of a CNN, and that is completely fine. But here in case of a language, right? Here in case of a language, you are not only supposed to train the weight, you are supposed to understand, you are supposed to remember a context as well. Suppose if you are going to ask me a question, right? So for sure, whenever you will try to ask me a question as of now, right? So you will try to ask me a question related to data science, related to a neural network, right? And so I have to understand that particular context, and based on that, I'll have to give an answer. If you are going to change a context, let's suppose if you are trying to ask me some kind of a personal question, right? Let's suppose if you're trying to ask me some kind of a question from a finance, right? From a banking, from some kind of a domain. So in that case, I'll have to change my context. And then based on that, I'm supposed to give you an answer. I'm supposed to give you an output. And this is where CNN fails. So CNN always try to train a weight to understand a relations of a static data, but it will not be able to, memorize, it will not be able to understand a context, right? And if it is not able to understand a context, so if I'm talking about a question answer system, you will not be able to build it. If I'm talking about maybe like a sentiment analysis system, you will not be able to build it. If I'm talking about some kind of a language translation, you will not be able to build it. If I'm talking about some kind of a fill in the blanks, right, you will not be able to do it. If I'm talking about a text summarization, right, you will not be able to do it. I think you must be using an insert where like we used to get a different news in in an abbreviation, right? So you must have seen that so they are trying to use basically a neural network based architecture in a backend to summarize a text. There are two kind of a summarization that you will be able to get. One is extractive and another one is abstractive. basically. We'll talk about that in a later stage for sure, that what is the meaning of abstractive and extractive. But in all of this situation, in all of this scenario, so you need some kind of a network which will not be able to understand only a weights or only a relationship between the data, but you need some kind of a network which will be able to remember a context, which will be able to memorize something from a past, which should be able to change its context based on the input that you are trying to give, and keeping these things in mind. So people have derived a network called as long short-term memory. And again, inside this network, there are like hundreds of variants of a LSTM network that you will be able to get, right? So the popularly known LSTM networks are RNN and LSTM. Now, what people have done over there? So people had said that okay, so it's completely fine. Let's suppose I have a neural network, right? I'm trying to give some kind of input. For sure, I will be able to get some kind of output, just like a CNN, right? Or basic of CNN. I'm not getting into a depth of CNN because it will be a all sort of different discussion, right? So let's suppose I'm talking about one kind of a neural network which will be able to get input, right? So input I will try to give, and then I will be able to get some kind of a output. That is completely fine. But what if, right? What if I will try to send some kind of a output back to the network itself, right? In this case, what will happen? So basically, in this case, it will be able to understand that what I have done last time, right? It will be able to understand, it will be able to memorize that what I have done last time. And if I will be able to get this kind of a network, right, for sure, I will be able to solve some kind of a problem. And keeping these things in our mind, so people have like a given you a network called as RNN, right? Inside RNN, so you will be able to get LSTM, and inside, so again, so another variants of RNN that you will be able to get is a GRU. So recurrent neural network people have discovered and people have developed, right? Which will be able to take an input, that is completely fine. It will be able to give you output, but it will be able to take a feedback as well, right? It will be able to take a feedback from our output to the input for the next one, right? And in this case, for sure, you will be able to, or for sure, your network will be able to understand a context. It will be able to memorize something, right? So people have developed long short-term memory and gated recurrent unit. In this one, so people have designed a different kind of a gates. I'm just trying to give you overview because Chris has already uploaded this videos, LSTM and GRU. So I'm expecting that you must have gone through those things. But yeah, I have to create a story for that, so that like this is what I'm trying to do in this particular place. Okay. So gated recurrent unit. So in this unit, you will be able to find out a forget gate. You will be able to find out a memory channel. You will be able to find out an output. So this is just a black box of this LSTM network. If you will try to search RNN LSTM, you will be able to see a complex architecture, a gated architecture, where you will be able to find out a forget gate, you will be able to find out a memory gate, and you will be able to find out an output gate. So forget gate is responsible for like a changing the context. Memory gate is responsible for memorizing something new or adding something new to the context, a previously learned context or a memory channel. And output gate is responsible for giving you a final output that you need, right? So this is something that people have derived, right? Now again, people have started facing some kind of an issue, because in case of let's suppose if I have to like if I have to build a question answering system, or let's suppose if I have to do a language translation, so I can go to a Google Translator and I can try to type an entire sentence. And for sure, Google Translator is supposed to understand each and every sentence, grammars that I'm like grammars of that particular sentence, and then it is supposed to give you some kind of a output. This is what Google Translator is supposed to do, right? Now, so here in case of like a LSTM, if I'm talking about, right, or in case of a GRU, if I'm talking about, so these networks are not that good alone, right? Alone. Again, I'm not saying that these networks are not good. I'm saying that these networks alone are not good to perform this kind of a task, where it will be able to take a multiple input, right? It will be able to learn, and then it will be able to give you a respective output for question answer system, for any kind of a Language translation, you must be receiving a mail nowadays since last 1.5 year. So Google has implemented a feature in a Gmail where it will be able to give you a response to your mail as well, right? 4 to 5 response based on the probability factor it try to give you. So unless and until this model is not able to understand your entire mail, how it will be able to generate an output, right? So we want some kind of a model which will be able to take n number of input. It will be able to understand, and based on the training that has been done on a huge data set, so it will be able to give you some kind of a output. And then people have started exploring about a new different kind of a technique, and people have discovered, or people have released one research paper that is called as sec to sec, or sequence to sequence learning with a neural network. And this is what we are going to talk about. This is the agenda that we are going to cover. So people have basically released this particular research paper which can solve this particular problem till certain extent, right? I'm not saying that it will be able to solve all of your problem. There are like a 25 plus tasks people used to define in an NLP to like to build, or like to test any kind of a model, right? So people came up with this particular idea that is called as sequence to sequence, right? So Ilyas Sekar, who was a main researcher along with like a Oriel and along with Avi Lee, so they have released this research paper, and then they have claimed that okay, so whatever issue that you are facing, so maybe this paper can solve that particular issue, maybe not 100%, but till certain extent, right? So I will be able to solve your problem. And keeping these things in our mind, so people have released this particular research paper called as sec to sec. Now, so let's try to understand, right? First of all, that what kind of a data input, or what kind of a different models that you will be able to encounter. So let me share my white screen now. So whenever you will try to work with NLP, right? So you are going to face a different kind of a, like a different kind of a situation, different kind of a scenario. So somewhere you will face that okay, so somewhere you will be you will try to see that there are a multiple input, right? There are a multiple input, and you are looking for basically a multiple output. You are looking for basically a multiple output in this particular case, right? So this is called as sec to sec. Means we are trying to give input as a sequence, and then we are trying to get output as a sequence. For example, so if I'll talk about your Gmail, right? So whenever you try to fire a mail, and it will try to generate a response. It will try to generate a response for the person to whom you have fired a mail, right? So it will try to give you a multi-word output possible, right? So you're trying to write something in by using a n words, and for sure Google will try to give you some kind of output by using m number of words, right? So maybe you can have n number of input and m number of output you will be able to generate. It could possible, right? It could possible that you will try to give a multiple input, but you will be looking for just one single output, right? You will be looking for one single output, and this is called as sec to vec, basically. So sequence to vector. Previous one was sequence to sequence. This one is sequence to a vector model. Basically, here you are looking for only one output, but as an input, you are trying to give a multiple data, right? Now, there could be another situation. There can be another scenario where you will try to give just one input, and you can expect a multiple output, and this is basically called as vec to sec. So we are trying to give one input, and we are expecting a multiple output over here, right? These are nothing but it's a feedback, right? It's a feedback from the previous one, as I said. So to remember the context, it always try to store the feedback. So there can be a vec to sec, right? And it could possible that you will try to give only one input, and you will be expecting only one output, right? So again, this situation is called as vec to vec. So we have sec to sec, we have sec to vec, we have vec to sec, and we have vec to vec, right? So these are the kind of a situation that you will be able to find out in terms of input and in terms of a output. Now, so whenever I'm talking about this one, right? So maybe I can try to replace these things with RNN cell, right? So any kind of RNN cell, maybe LSTM, maybe GRU, right? So this cell can be anything, This is basically a cell. This is not a neuron. Many people think that I'm talking about a neurons over here, but no, this is not a neuron at all. It's a cell which I'm talking about, right? It's a complete cell. Inside that, you will be able to find out a forget gate, a memory gate, and the output gate, right? If you will try to go through a Chris channel, and if you'll try to understand this RNN network, right, that he has already uploaded a long back, right? So these are nothing but it's a cell, right? So what we have done is, so we can try to combine each and every cell, and then we can try to build this entire network. But still here you will be able to find out that we are trying to give an input, we are trying to take an output from each and every cell. It is possible that it will not be able to serve a purpose, right? It is possible that it will not be able to give you a better accuracy or a better result. And keeping these things in our mind, because we already had a basic of basic RNN cell, we already had a LSTM, we already had a GRU, which will be able to understand a context, which will be able to memorize a previous one, right? A feedback of the previous one, and which will be able to give you an output. But people thought of an idea, people have started thinking about a new idea, and people said that, okay, so what if I can try to separate input and output, right? If I can separate input and output, if I'll try to separate the entire network of input, and if I'll try to separate entire network of output, in this way, what will happen? Whether I will be able to achieve like a better result in terms of language translation, in terms of question answering, in terms of fill in the blanks, in terms of text summarization, text abbreviation, right? In terms of maybe like some kind of a fill in the blanks, right? So people have started thinking about this and keeping these things in mind. So they have released that particular paper that is called as Sequence to Sequence by Ilyas Satsekar. And this is one of the breakthrough that people have made, right? And after that, so there are like a many different kind of a research paper that people have released, which is responsible for solving a different kind of a real world problem that we used to see in a current situation, in a current environment. Now, when I talk about this paper, right? So again, so you're not supposed to go through this entire paper. You're not supposed to read out this entire each and every line, right? So you're just supposed to understand architecture and a mathematics behind that. If you're able to understand it, it's completely fine. Just for once, if you'll go through this entire paper, you will be able to understand, because that is the core, that is a base of each and everything, right? Now, so let's talk about this sequence to sequence research paper, and let's try to understand that how it is going to solve a problem, what kind of a problem it is going to solve, and how we can try to utilize these things, how we can try to use these things by using this code, right? So how I will be able to train my model, how I will be able to build my own chatbot, how I will be able to build my own language translator, how I will be able to build a kind of a model which will be able to do a text summarization, right? So let's try to understand this sequence to sequence paper. I'll try to restrict myself just to this particular paper, so that you will be able to get a neat and clean, a very clear understanding. And along with that, you all will be able to understand Encoder Decoder, which is going to help you out to understand transformer, and a research paper called as Attention is All That You Need. Because this is where we have to reach out, right? Attention is all that we need. Okay, so now let's start talking about this research paper. So here, right here, so from this research paper, a concept of encoder decoder came into a picture. We already had a sec to sec, sec to vec, vec to vec, and sec to vec, right? But people said that, okay, so what if I'll try to like separate a input network and the output network all together, right? In this case, what will happen? What I will be able to achieve, right? So people have separated this input and output network, and they said this input network, they have named this input network as a encoder. So whenever we talk about encoder, it's nothing but it's a input network which will be responsible for taking an input and understanding a relationship between the inputs based on the loss, based on the difference between y and y hat that you will be able to receive. So here in this particular research paper, you will be able to find out, or you will be able to see two section, right? Two section. So here you will be able to find out this section, as well as you will be able to find out this particular section, right? So here you can try to see that this is a network. These are nothing but it's a cell, you can say. So the basic RNN cell, LSTM or GRU that you have studied so far, so forth. So this is nothing but it's a cell. It's basically a RNN cell. It could be a LSTM, it could be GRU, and a variety of a different kind of a cell. So now here you will be able to observe that we are just trying to give some sort of a input inside this network, nothing else we are trying to give inside this one. Now after taking an input, so we all know that if I'll talk about RNN LSTM, right? So RNN LSTM is kind of a neural network which will be able to change. So based on the context change or based on the memory gate, so it will be able to give you some output. So it will not give you output just based on the weight which is been trained. It will try to give you output even along with like feedback that it has taken from the past, right? So here what people have done is, so people said that, okay, fine, so like let's try to like separate this input and output. Let's suppose as an input I'm trying to give one sentence, right? So like I'm trying to give like I am fine, right? So let's suppose this is the input which I have given, right? Now it is supposed to perform one task. It is supposed to translate, it is supposed to convert this I am fine, right, into a respective Hindi language, right? So here probably I can look for mera, okay, sorry, I'm not good with like I think this is how, sorry, my bad. So ठीक हूँ, right? So this is what a kind of a output which I'm expecting, right? So I'm trying to give an input and I'm trying to get an output, right? So this is the kind of a output which I'm expecting, right? Now here you will be able to find out one very interesting things, right? This is a very small and very simple example, but the interesting thing over here is that I'm trying to give I, fine. Translation of I is मैं, it's completely fine. Am, right? So we are not trying to give, or we are not trying to get a exact same output as an input in the same sequence. Like I said, so whenever we deal with the language, so it's not like one-to-one mapping. So you can try to give any kind of a sequences, and then after translation, it is supposed to generate a respective meanings, right? It is not supposed to maintain the sequence. Sequence can be anything. It's not a one-to-one word mapping. Otherwise, we would have done that with the help of some kind of a NLTK library, SPACY or GenSim libraries, right? But no, we can't do that basically, because again, so the way I can like try to like give some input and the way other person will try to give an input can be different. But it could possible that we are trying to like generate, we are trying to form a similar kind of a meaning, right? So here, basically, this is the input network, right? This is the input network that people have proposed. And this input network is called as encoder, basically, which will be responsible just for taking an input, nothing else. It will try to take the input. Now, here you will be able to find out that we are trying to use some kind of a RNN kind of a network, right? Because we have an input, it's completely fine, and we have a feedback. It's not an output. So don't try to misunderstand that this is representing an output. No, not at all. It is basically trying to represent feedback, basically. So it will try to take some input, and then it will try to like take a multiple input, as you can see, right, from a different like a input channel from the different cell, and then all of these things are trying to give a feedback. All of these things are a neural network, RNN LSTM, RNN GRU based network, which will try to understand a meaning in between all of these words. And here we are able to see end of a string, right? So that it will be able to understand that, okay, fine, so this is the end of a string, right? This is just a token that people have given, right? This is just a token, so that it will be able to understand. Now, let's suppose if I'm trying to talk about maybe a sentence with a 10 different words, 10 words, right? So in that case, I can try to increase the number of the input network, or maybe I can try to create a steps in which I can try to give an input. So Basically, encoder is nothing but it's basically a RNN LSTM based network which is responsible for taking an input. That's it. And then it will try to understand, it will try to understand the context, it will try to understand our relations, means weight basically, and then it will try to give you a final context vector or final context weight over here. So this is called as a context vector, I can say. This is the context vector. Now, what is the meaning of context vector, right? So we are trying to give a multiple input, right? We have given I am fine, right? This is something which I have given as an input. Now, so it is trying to understand, it is trying to summarize each and every word, and then it is trying to send this input, right? Send this context vector as an input to a different network. So this is basically a whole sort of a different network that people have released, that people have built, where so you are trying to give a input from the previous network, from the encoder network, and here you will be able to find out that we have an output over here, and this output network is called as decoder, right? So this is basically called as a decoder. Now, how decoder works? Or let's talk about one situation, right? Let's try to understand that how in a very first place training happens, right? So if I'll talk about training, so in case of a training, what I will do is, so I can try to prepare my data. So I can have an English sentence, right? And I can have a Hindi sentence. So these are the these are the data which I can prepare. Now I can have a multiple English sentences and its respective Hindi sentences I can have. This is a data which is going to, this is the input data which is going to work for me as a training data at the time of training. Because let's suppose if I'm trying to train my model from the very scratch, right? I have just designed the neural network. Now let's suppose I'm trying to train these things for the very first time. So for sure, I will try to give what? I will try to give English sentence. I will try to give its respective Hindi sentence, right? Maybe I can try to prepare all of those data manually, right? Fine. Now, after doing that, right? After doing that, so we can try to convert this data, right? We can try to convert this data into a embedding vectors. Embedding vectors, because for sure your network will not be able to understand, right? Your network will not be able to understand your English word or your Hindi word, right? It's just like some kind of a ASCII character for a system. So your system will be able to understand some kind of a numerical representation. So we can try to like do a numerical representation. So we can try to create our embedding vectors by using some kind of a pre-trained network, or maybe by using some kind of a algorithm like a TF-IDF, or maybe a sentence tokenizer. Maybe I can try to use a globe model. Maybe I can try to use a word to vector, right? So by using these things, I will be able to generate a respective numerical values of my English sentence and my Hindi sentence. I will be able to do that. Now, once I will be able to get our embedding vectors, then this embedding vectors for English, right? Embedding vectors for English will go as an input. So it will go as an input over here inside your encoder decoder network. So this English sentence will get inside this network as an input. That is completely fine. And here as an output, so you can expect Hindi word. So you can say that this is my XI, and you can say that this is my YI, right? So whenever you will try to give XI, so for sure it is going to give you YI hat, right? Means this is the predicted value. This is going to give you a prediction. This is a predicted value that it will be able to give you, right? Now this is the expected one. It's a predicted one. It's an expected one. For sure, there will be a differences. You will be able to find out. It means what? It means you will be able to find out loss. Once you will be able to find out loss or cost, then what you will do? Then you will try to back propagate. You will try to back propagate from a decoder to encoder by saying that no, whatever input you are trying to give it to me, it is trying to give me some kind of a loss, right? It is giving me some kind of a cost. Means there is some error. There is some difference between my expected Y value and the predicted Y value. There is a difference between YI and YI hat, right? So in a backward propagation, it will try to update the weights. It will try to change the weights. Just try to understand this part. So here, all of these cell are nothing but it's a RNN cell. Any kind of a RNN cell you can say. So these are nothing but it's a RNN cell. It's not a neuron. It's just not a neuron. One single perceptron. You can't say that, right? These are basically a RNN cell. It's completely fine, right? So you have given English sentence as an input, as a X, and then you are able to get, so you are giving like a Hindi sentence as a Y, right? So at the time of training, I'm just trying to talk about a situation of a training. So at the time of training, what will happen is, so at the time of training, what will happen is, so it will try to take input. So let me like erase all of those things. Okay. Okay, so at the time of training, so what you're trying to do, so you are trying to pass basically a English sentence, and here, so you are expecting some output in Hindi sentence, right? So this is the output that you are expecting. You can say these things as a YI. So YI, and then for a respective XI that you are trying to pass, right? For sure, it is going to give, this is just expectation, right? This is just expectation. What output that you will be able to get? You will be able to get basically YI hat, right? So so you will try to find out a difference between YI hat and a YI basically, right? That is something called as a loss or cost or error that you will be able to get. Now you are going to send this loss inside a optimizer. So in case of optimization, what will happen? So it will try to backpropagate throughout the network across the time axis, right? So it is going to backpropagate basically across the time axis, and then it will try to train itself. It will try to when I'm saying train itself, it means what? It simply means that it will try to update a weight over here, 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 and here. It will try to update the weights so that it will be able to understand a relation in a better way. Again, it will try to give some input, right? So it will keep on giving all the input that we have taken over here, right? And it will keep on adjusting its weight, right? Even in this network, it will keep on adjusting its weight. And once this model will be trained, so here, the main idea or the main agenda is to talk about encoder decoder, right? So this network, right? This network, as I said, this is the input network and this is the output network. So this is called as encoder and this is called as a decoder. Now, at the time of testing, at the time of prediction, what will happen? So you are going to give input over here. So suppose if I have a sentence, right? So I can try to give an input over here. It will try to generate its respective context vector. And then it will try to pass this value to this one, right? It will try to pass this value to this one and it will try to generate some output. Then this output, right? This output, as you can see, this output you are trying to send again over here to the next network. This output you are trying to send again to the next network. This output you are trying to send again to the next network, right? So whatever output that you are, because whenever I'm trying to do a language translation, right? So in case of a language translation in terms of like a question answering, so I'm supposed to understand a previous context as well, whatever I'm trying to say, right? If I'm not able to correlate this sentence which I'm trying to say as of now with respect to the sentence which I have just said 1 second back, right? For sure, I will not be able to make any kind of a sense, right? So in this is what this network does. So in case of an encoder, take an input, try to understand an entire relationship between the input sentences with respect to output sentences, try to do a backward propagation based on the loss, try to train itself, and then finally, right? And then finally, what will happen is, so then finally it should be able to give this word context vector. This is nothing but it's a context vector to the input, as an input to the decoder network, which will start decoding your sentences one by one, and then it will be able to give you a final outcome. Like if I'm saying I'm fine, so it will be able to translate back these things to the like a matic whom, right? And then end of the string. So end of the string, as a end of the string, so it can try to give you full stop or maybe exclamation marks, maybe kind of a question marks or any kind of a thing. But this is just a notation. This is just a notation that, okay, fine. So now you have to stop, right? After that, we don't have to generate any kind of a things. So whatever it will generate in this area, it is going to give you this as an output. But again, people have started facing some kind of a issue, right? Here, if you will just try to like a focus, right? If you try to focus, so here in this area, we are trying to give, or we are trying to propagate our data just in one direction. If you'll see, right? If you'll see over here, so we are just able to propagate our data into one direction. Now, whenever we are talking about sentence, right? So in case of a sentence, of if I'm trying to generate some kind of a word, so a word before, like some kind of a word before that word and after that word also matters, right? To understand the context, for sure. So let's suppose, like I have given you example that if I'm talking about like bull is going high, right? So a bull is going, right? Suppose if I have just written a sentence like bull is going, what you will be able to understand? I don't think that you will be able to understand that I'm talking about a finance market, I'm talking about the stock market, right? But if I'm saying that bull is going high, then only you are able to understand, or like when I'm saying bull is going high, and if you're able to understand the context that, okay, fine, I'm talking about these things in terms of finance, and so you will be able to understand that, okay, fine, so what is the actual meaning, what I'm trying to convey, what I'm trying to represent. But if I'm just saying that, okay, fine, bull is going, you will understand that, okay, fine, so I'm just talking about some animal which is going, right, which is going somewhere. You will not be able to understand that share market is going up, right? So in case of a sentence, right, a word which you are going to take before and the word that you are going to take after, that matters a lot. But here in this network, right, so you will be able to find out that my data set is propagating just in one direction, right? But what if, right, then again people have started thinking about a new approach, new idea. So I think like we all are able to understand encoder decoder. So encoder decoder are nothing but input and output kind of a network, right? Inside encoder I can have like any kind of a basic network. Inside decoder I can have any kind of a basic network. In the encoder I can try to give any kind of output. I can try to create any number of the cell, not a neuron cell, which can take an input, and in our decoder we can try to create any number of cell which can give me output. That is completely fine. Now, so here I was talking about basically like a kind of a situation where you have to understand a context before and after. You have to understand a word before and after as well, right? And this is not a network which will be able to understand your data in both the direction, right? This is basically a network which will be able to understand a data just in one direction, right? So what we should do in this case, then people have proposed, right? People have proposed that what if we are going to use a bidirectional LSTM or a bidirectional RNN cell over here, right? In this case, maybe I will be able to solve this problem. So people have started coming up with the idea that, okay, so let's try to build a kind of a network. Let's try to build a kind of a network which will try to take a data, right? Which will try to take a data, but they will try to propagate this feedback as well as output, right, in both directions. So for sure I will come to this topic. I'll try to talk about this one, like what is the issue with the bidirectional, like what is the issue with the, but yes, this is not the best network that we are talking about, right? We are just talking about a basic of encoder, basic of decoder over here. Then people come up with the bidirectional LSTM, bidirectional like a encoder. So inside that, a base network can be a bidirectional. Inside that, I can try to keep maybe a deep RNN, maybe a deep LSTM, deep GRU, means a stack of RNN, a stack of GRU I can try to keep. In this way, it will be able to understand our relations in a better way. It will be able to memorize a context in a better way. That we will try to explore, that we will try to understand. But let's try to complete this topic. So this is what people have proposed in terms of a sequence to sequence. Means I'm trying to give one sequence and then I'm able to get one output as a sequence. Now, okay, So now here you will be able to find out that people have given one function, right? Let's try to understand this function as well, right? I was talking about basically encoder and decoder, right? Now here in this one, you will be able to find out that this is the sigmoid, right? Now, what this sigmoid is trying to take, right? And what is our meaning of this HT in this particular research paper? So this HT is nothing but, right? So this HT is the HT that you are able to get is nothing but it's a kind of a output that you can expect from one particular cell, right? So here you will be able to find out that whenever I'm talking about a sigmoid, like whenever I'm trying to talk about like a HT, right? So this is nothing but it will be an output from this sigmoid function, which is trying to take basically a weight of x at time t and weight of this one at time t minus 1, right? So basically it is trying to consider a current data as well as means current input is able to understand, as well as it is trying to understand some kind of a feedback, right? This HT is nothing but it's a feedback from the previous one. That's the reason it's a HT. HT is basically for the output, right? H is basically representation for the output in this research paper. So here you will be able to find out that here it is trying to take some weight. It is not trying to take exact output as an input. No, it's not like that. It is trying to take some weightage of the output as an input to the next layer, and this is what is been represented and based on current input and the output. So it is trying to give you what? It is trying to give you a final result. It is trying to give you a final prediction in this particular area, in this particular place. Okay, so now this is what a model always try to do, and that's the reason they have mentioned that the recurrent neural network is a neural generation for the feed forward neural network to the sequence. Given a sequence input, suppose if I'm trying to give a sequence input from like a x1 to xt, right, on a time axis, basically suppose if I'm trying to give n number of input, right, so it will try to get into a RNN, and a standard RNN computes a sequence of the output by iterating the following equation, right? So it will try to first of all calculate this one, and then finally it is trying to multiply this HT with a weightage, and then you will be able to get this final outcome. So to calculate this final outcome, you are supposed to calculate first of all h of t, and to calculate h of t, we are trying to consider a weight from the current context, from the current input, as well as we are trying to find, or we are trying to take input from the feed forward or from the feedback network as well, from the previous network as well. And this is what like this system does. Now, in a later stage, they have mentioned that RNN can easily map sequence to sequence whenever the alignment between input and output is known ahead of time. Now, what is the meaning of this one? So the meaning of this one is very simple, that whenever you will be able to get, or you will be able to give a data which is mapped. Means let's suppose I'm talking about English and Hindi. If you are trying to give a mapped data, that okay fine, so for this input this is the output which I'm expecting, so for sure it will be able to align itself. It will be able to align itself means it will be able to understand our relations in a backward propagation. It will be able to understand a relation in a backward propagation, and then accordingly it will be able to tune, it will be able to train its weight, it will be able to adjust its weight, and finally it will be able to give you an output here. So again, you will be able to find out this formula which has been used, right? This which has been used for our internal hidden layer calculation. So basically it is trying to give you a probability of finding some word, probability of giving you some kind of a output out of the n number of the n number of the probability. So here you will be able to find out that it is trying to give you some kind of a YT, and basically it is trying to find out the probability of giving you a YT when some sentence or some input has given. This is the meaning of this particular equation that you will be able to find out. So it is trying to give you a probability of giving you an output as a Y, right? Output as a Y when some input has given to you, when something has known to you, right? It means that when you already have some kind of an input, and when you have already learned some kind of a weight, and this is what it is going to give it to you. So it is, so here we are just trying to find out that what is the probability of getting this when this all of those things is given, right? So you must have seen a naive Bayes equation. So naive Bayes equation, so we used to talk about probability of A of B. So it's nothing but probability of occurrence of A when B is given to us based on same thing. So it is trying to give you some sort of a output. So based on your input and based on the learnings that it is going to do internally, so it will try to give you an output in a simplest possible way. Now, if I'll try to move ahead, right? So if I'll try to move ahead, so here you will be able to find out decoder side. So in a decoder side, so yes, it is just going to give you like a output one by one output from each and every decoder output network that has been given to us. And here they have given you just a benchmarking in terms of like with what in all a data set, what kind of a training that they have done, what was a total number of the cell that they have created. So 1,000 cell at each layer, the 1,000 dimensional word embeddings they have used. So this is the specification that they have given to you when they have written this research paper. It doesn't mean that whenever you will try to build your network, you are supposed to follow a same thing. It could possible that you can try to change, and in general, yes, we do change all of those things whenever we try to train our own network. It's just a hypermeter. When I'll talk about a code, you will be able to understand that, okay, fine, so code is nothing, anyone can write it down and anyone will be able to implement it. Now, so here you will be able to find out basically benchmarking. So here for a language translation, right? For the language translation, so they have given you a BELU score, BLU. So blue score they have given to you, BLEU. So it simply means that bilingual evaluation understudy. This is the meaning of this BELU score. So for any kind of a problem statement which is related to a language translation, I'm just talking about language translation. I'm not talking about entire NLP, right? So for any kind of a language translation, so we always try to calculate a what BELU score, basically a bilingual evaluation understudy. So this is what a kind of a score that we use to calculate. And here, if you'll try to go through this research paper, so you will be able to find out that a single forward LSTM with a beam size of 12 means a size of a network is equal to a 12 single forward in a single direction, right? So this was the BELU score which they have received. Then ensemble with the 5 reversed LSTM, beam size is equal to 1. So they have received this as a BELU score. Ensemble with 5 reversed LSTM, beam size 12. So this is the BELU score. Basically, this is what a kind of a standard result they have given to you based on the standard data set. So whenever you try to write some kind of a research paper, so people always try to mention their findings, people always try to mention about the data set, people always try to mention about their accuracy that they were able to achieve, people always try to mention basically a different networks and experiments that they have done. So whenever, even if you are going to write some kind of a paper in a future, so for sure you are supposed to follow a same kind of a same set of a scenario, and then you will be able to like build some better kind of a model. Now again, right, so these are the models benchmarking that people have given to you. So again, you're not supposed to look into all the models, you're not supposed to study, because all of them are like a sequence to sequence model itself. Means there will be an encoder, there will be a decoder, and you will try to give some input, it will try to give you some kind of a output in this particular way. Now again, so they have like built a model. So here you will be able to find out that here they are trying to give 1,000 best with the 1,000 best with an ensemble of 5 reversed LSTM, and this is the score that they were able to get. Now if you try to find out this network, yes, you will be able to find out a design and architecture of this network in the easiest possible way over the internet, right? And all of these things is been performed based on this particular data set, NTST 14 data set. So they have like a basically like a French test set data set. So they have performed this kind of a like a this kind of operations they have performed on top of this one, right? So here, yeah, so they have released a truth ratio as well, and finally a conclusion that you will be able to find out. Now, so let's come to this one. This is the architecture. This is the previous one was basically a sec to sec model. It was a very generalized structure. Now, so any kind of a model that you will be able to build based on sec to sec, that is completely fine. It depends upon me that how many input that I'm supposed to give in my encoder side, how many output I'm supposed to receive in a decoder side, right? So sec to sec was a basic, I would say, a fundamental papers that people have released. Now, based on that, based on that, so people have designed a different kind of a network, and people have derived a different kind of a situation. People have derived a different kind of a scenario. Now in this paper, right, in this paper you will be able to understand the actual effect of, or actual calculation, or the actual phenomena which happens, actual things which happens behind the scene of a encoder and decoder. So the name of the research paper is effective modeling of encoder decoder architecture for joint entity and relations extraction. So entity recognition, name entity recognition, let's suppose if I have to like detect a name from the entire sentence which has been given to me, name of a person, name of a place, name of maybe a building, right, name of the street, name of the animal, name of the word, or a relation extraction. Suppose if I have to understand the relations, maybe based on the noun, pronoun, verb, adjective, verb, all POS, parts of a speech, right? So this is basically a research paper which people have designed, which solves different purposes, but based on same sec to sec paper that we were talking about. And here in this research paper, you will be able to find out, again, base is same, right? Base is same. You have an encoder model, you have a decoder model, right? But again, inside an encoder model, it could possible that I can try to use like a unidirectional LSTM, or maybe I can try to use a bidirectional LSTM. It could possible that I may end up using a stack of LSTM, which is called as a deep LSTM, or deep RNN cell I will end up using in both of the side, or maybe in a one of the side, right? So based on like this phenomena, so the other paper has been written. So before moving to the next part, so maybe what we can do is we can try to take some question, right, Chris? Are you with me?
Yes, Rancho, I'm here.
Yeah. So if we have any kind of a question, so we can try to take those questions.
Again, people are asking about community classes, so nothing with related to this.
Okay, so nothing related to encoder decoder.
Guys, any questions with respect to encoder decoder, please do ask. Anything that you have with respect to encoder decoder, any questions, so that he'll move ahead, everyone? Okay, I think no questions as such. Can you share the PDF? Just
Yeah, so after this like a
I'll
discussion,
put that in the description, guys.
we can try to share this one.
Any reason there is a feedback from encoder to decoder as well, along with the output from encoder as input of encoder? What does this mean?
What is this? Any reason there is a feedback from the encoder to decoder as well, along with the output from encoder as a input of a decoder? See, the thing is like in terms of encoder, right? So it is responsible for just for taking the input data. So it will try to give you just one output, and that is called as basically a context vector, or like a weightage of the learning that it has. So context vector of the entire sentences, it is going to give it to you. That is one thing, right? And decoder is a kind of a network which is responsible for like taking this context vector as an input, and then it will try to give you an output. Now, so in general what happens is, so once decoder will try to take this as an input, and then it will try to give you some kind of output. Now after that, let's try to like get back to our slide over here. Yeah, so here what you will be able to find out is like so this is the encoder network, that is fine, and this is basically a decoder network, like I said. So it will just take an input, and a decoder will just try to give you some kind of output. Now once like an encoder will try to give you just a context vector, right? Based on that, it will start giving you output. Now, so whenever I'm trying to get some output at the time of training, right? Whenever I'm trying to get some output at the time of training, so it could possible that I was expecting something else and it has given me something else. That is called as a y hat, or I can say y. So y hat is nothing but it's a predicted value, means it's the output given by your model, and y is nothing but what I'm expecting at the time of training. I'm talking about, I'm not talking about at the time of testing, right? So at the time of training, so it will try to give you this as an output, and this is the input that it can expect. Like this is the expected output that you have. Now, so if there is a differences, so for sure it is supposed to give a, it is supposed to do a backward propagation, because unless and until you are not able to do a backward propagation, for sure you will not be able to adjust a weight of all of this layer, which is consist of a RNN cell or a variety of variants of the RNN cell, like a LSTM or a GRU. So that's the reason. So we have like a encoder and a decoder, and I think this was the question, right, Chris?
I did not understand the question only. Okay, I think you
Whatever I
have.
understood, right? So based on that, I'm like trying to give answer
Okay.
to this question.
Okay. What does reversed beam means? What is this?
Sorry,
Beam.
reversed, guys. So if you can
Beam.
write your question in better way, I think we can understand, and then we can try to explain you these things.
I think you can continue, Sudhanshu. At end we'll take. Okay, amazing explanation. Encoder is a part of sequence
Okay,
to
someone is
sequence.
asking
Yes.
that is it's only used for language translation.
No, no.
So no, Amit, it's not like that. It can be used for the language translation. It can be used for like a name entity recognition. It can be used for like a sentence tokenization. It can be used for like a question system. It can be used for the extractive summarization. It can be used for a fill in the blank. So there are multiple tasks which it will be able to perform, but the thing over here is, so based on the task, people have modified a different networks, right? And based on like your task, you can try to use a different architecture. What I'm talking about as of now is a basic of or evaluation of this particular sequence to sequence model, because after that people have discovered this like an encoder decoder, or people have started talking about transformers, or like a auto encoder, or like a attention based model, which is bot elmo GPT-1, GPT-2, and so on, right? So basically this is the just a base. This is a starting of an NLP I'm talking about. But before that, for sure, like you are supposed to know RNLSTM, as Chris has already like declared these things in his channel, right? So if you will not be able to understand RNLSTM or like RNGRU, right, so it will be a bit difficult for you for sure.
Yep. Okay.
So
One
in
question
short,
one person is asking is that
it's used in all NLP based tasks. Yes, but not the same network. It's not like you will build just one network and will be able to solve all the problems. So based on the problem statement, we keep on like we keep on changing the network architecture, right? So I'm just talking about a generic approach, right? So what will happen and how it will be able to understand, because everything it's all about what? It's all about understanding your sentence, understanding a context in both the direction or maybe into a unidirection. If I'm able to, because now you are able to ask some question, how? Because I was trying to explain something, right? Somewhere in between you are confused, and then based on that you're trying to raise some kind of a concern. It means that you are able to understand a context. You're trying to ask some question in terms of NLP itself. You're not asking some question from finance or from physics or from mathematics or from biology. You're trying to ask a question from an NLP itself. How? Because you are able to understand a context, and based on the context and based on the paper which I'm talking about, we're just trying raising the concern. So now this is again one scenario. This is a same thing which my network is supposed to understand, right?
okay, I think
Where
Sudhanshu
are
can
these
continue.
model mostly applied? So if I'll talk about your WhatsApp message system, right? So in your WhatsApp, let me give you a very simple example. Let's suppose if you will type my name, right? Let's suppose if you type my name. So for the first time, if you type my name, for sure my name is not a part of dictionary. It is not going to give you any kind of a like a hint, right? It will give you some random hints. But if you will type my name twice or thrice, right? What you will do, what you will get. So after some time, so it will start giving you some kind of a proposal. It will, so in an auto completion, so basically in your WhatsApp messaging system, so it will start giving you some kind of proposal, right? And this is where you can apply it. Now another scenario, suppose if I'm trying to build a chatbot from a very scratch, right? So again you need this kind of a model. So okay, maybe like in next session, so I'll try to show you one chatbot that we have built for one client, that is basically like a custom chatbot. Like we have not used any kind of a predefined framework. We have just used a basic network, and based on that we have built a chatbot, and you will be able to find out that how good it is. to to communicate with you, and how good it is to understand a context, and that too in Arabic and as well as in English. So it will be able to understand all of the context, and it will be able to give you all the answer. So in that kind of system, yes, you can use it. Suppose if you are trying to build some kind of a self-responsive system, right, which will be able to auto reply to some of the sentences, some of the chat. Again, in that case, you can try to use it. Suppose if you're using some like a app called as InSort, right? So I think most of you must be using like a InSort app. So you must have seen that they will not show you entire news. They will just show you the abbreviation. They will just show you the chunk of the news. They will just show you the abbreviation of the news, right? Again, in that case, in case of a summarization, you can use it, right? Suppose if I'm trying to write some sentences, right, and in between those sentences I've not I've missed some of the word. It means I have to do a fill in the blanks, right? In that case, I can use it. Suppose I'm talking about Grammarly, right? It is supposed to understand the punctuation. It is supposed to understand the parts of a speech, and based on that, it is supposed to correct itself, right? I can use it. I can use this one, this particular model, right? So these are the real world situation. These are the real world scenario in which we are not supposed to just use. We are using it actually. Grammarly, yes, we are using it. Gmail, yes, we are using it. WhatsApp, we are using it. Chatbot, yes, we are using it, right? So in all of this system, you can try to use this sequence to sequence kind of a model, encoder decoder kind of a model, which can solve you many of your real world problem. Yeah. Now, so what is next? What type of architecture Google Translator use? So as of now, it is using basically a transfer learning based architecture, right? So I can't say that it is. So initially, because this is the paper, you can just see over here that this is the paper released by people from Google itself, right? So at that point of a time, yes, they were facing an issue, and at that point of a time, so they have used this sequence to sequence model. But if I'll talk about a current situation, right, now they are not using this basic sequence to sequence. They are using basically a transfer learning based model. It can be a BERT, Elmo, GPT-1, GPT-2, Albert, Electra, any kind of a thing, right? So can we use for sentiment analysis also? Yes, you can use it. So basically that situation is called as set to vec. Means you will give a multiple output, but you are expecting just one output. Multiple input, one output. Means you will give just entire sentence, entire phrase, entire paragraph, and then you can expect just one output. So yes, in sentiment analysis, and people generally try to solve a sentiment analysis problem by using a machine learning approach, right? Machine learning approach is not going to give you a best accuracy. Yes, you will be able to train the model. There is no doubt. Many people have done that, right? But if you are going to use this particular approach, sequence to sequence approach, right? And if your base model is maybe LSTM or GRU, you can just try this out, and you will be able to find out that yes, it is going to perform in a much better way as compared to your previous model, right? So yes, in like a sentiment analysis, blindly you can try to use it. After some time, just I'll take a couple of questions after that, so I'll just give you a walkthrough of this entire code. And again, code is not tough at all. It's very easy. What is the benefit of dividing sequence model to the encoder decoder as the functionality is same? See, so what people have seen over here is that okay, let me talk about one situation over here. So why people have divided input and output? That is actually a very good question, right? You are the first one who has asked this question in this session. Generally in my class, many people used to ask me. So see, what happens is, what is encoder decoder? So in case of encoder decoder, we'll be having one network over here, and we'll be having another network over here. Inside this network, so I can have this kind of a cell. I can have this kind of a cell. This is going to give you like a context vector, and inside this one, I can have like input and output. Okay, so here end of string. This is my xi. This is my x1, I can say. This is my x2, I can say. And here, let's suppose I am expecting y1, maybe y2. All these things are just a predicted value. And then I can say like EOS, end of string. Okay. Now, so in this case, what will happen is okay, these two networks are connected, and this will get as an input inside this one. Let me change a color of my pen. So here it goes. Okay. So this will get inside this one, and this one. And this is how these things are connected. This is how, now here. Now, the question is, right? The question is, so it's completely fine when we are trying to do a same thing, right? When we have a similar kind of a network or the kind of a base model in input and output, as well as like in an encoder, as well as into a decoder, then why do we need it, right? Here, let's try to understand this one. Let's suppose I have another network, right? I have this network where I don't have input and output in a separate way. What I have is I have an input, and along with that, I have an output network. Let's suppose I'm talking about this basic implementation. All of these round figures are nothing but it's a, let's suppose RNN LSTM I'm trying to use. Now here what will happen, it will try to take one input, right? It will try to give you some output. Again, it will try to take one input, it will try to give you some output. But let's suppose, so here I have given input as I am fine, right? Here it is supposed to give me mera, so main theek hoon, right? Here it is supposed to give me main theek hoon. Now sequence of this input is not same as a sequence of the output, or if I will try to translate, so here main hoon, you can say, or theek. Now, if I'll just translate in this way, right? Because if I'll try to understand this particular network, so if I'll start translating in this, because I don't know, because when I'm trying to give this output, right, I don't have even an idea that what I can expect in our second phase, right? So basically, this was an issue with this kind of a basic network that we already have. So yes, people have used this kind of a network. Even you can use this kind of a network to solve some time series based problem, to solve some kind of a time series based data, or maybe if you have a time series based numerical data, multivariate or univariate time series analysis, if you're trying to do, yes, you can use it, you can try to solve it. There won't be any kind of a issue, because over there dependency will be not much in terms of a previous context, or the previous, like a previous context that you have and the next one. But when I'm talking about a sentence, so whatever I'm trying to give as an output after my next output can depends on the previous output, or it could possible that it can depends on the whole sentence itself, right? It may depends on the whole sentence, means on the whole input, unless and until, for example, I was trying to give you one example, right? Suppose if I'm giving you one sentence, bull is going, right? What you will be able to understand if I'm saying bull is going, right? I have given you a sentence, you will be able to understand that, okay, fine, I'm talking about some animal which is going, right? But if I'm saying that bull is going high, now you will be able to like change the context, you will be able to understand the actual context. So when I'm able to get a last word called as high, then I'm able to form the meaning of the entire sentence. So unless and until I'm not able to understand the relation of the whole sentence, I'm not in a position to give you an output. Basically, I'm not in a position to give you some kind of a context. And this is where what people have done, people have separated this input as an encoder and output as a decoder to resolve the complexity of a sentences. But yes, you can try to use even this kind of a network to solve another kind of a problem, maybe time series. Yes, it will work fine, and you will be able to solve it with the help of this kind of a network. So I think I'm making sense to people who have asked this question. Okay, so who will decide when we have to put a stop word output end of a string? So see, whenever we design the network architecture, right? So we try to like take maybe 100 cell at a time. So basically we used to define that, okay, fine, so I will be able to take input just as 100 number of the cell, right? I will be able to take just as input maybe 200 or maybe 1,000. So this is us who used to design or who used to define when we are trying to create a network architecture for the very first time. I think I'm making sense. If we can use the latest and the best architecture present, then should we invest time to on our outdated architecture? No, you should not invest a time on the outdated architecture, but The thing is, everything is connected. That's the reason. So like Chris has asked me to talk about a BERT directly, but I said that no. So instead of like getting into a BERT directly, right, we should talk about attention. To understand the attention paper, the attention is because in attention, so we are going to talk about heavy mathematics. Here we don't have any kind of like a heavy mathematics at all. It's more like a theoretical things, right? But in attention model, so it's a heavy mathematics that I used to discuss, I used to talk about. And to understand the attention, so before that, what you have to do, so you have to understand basically transformers. To understand transformer, you have to understand encoder decoder. To understand encoder decoder, you should know sequence to sequence. To know sequence to sequence, you should know a basic like a RNN LSTM or RNN GRU, right? So that's the reason. So you should know about the previous architecture so that you will be able to learn new things in a best possible way. Okay, so now let's talk about like just a code walkthrough, right? Maybe at the end of this session, so I will try to give you some example maybe in our next class. So I'll try to show you name entity recognition model as well. So when I will end up talking about like a transformer model, because after this I will be talking about transformer model itself and based on the encoder decoder architecture, right? So here code wise, if you will try to understand, right, so you will be able to find out that coding is like a very easy, right? It's not at all tough. Now let's talk about like a encoder and a decoder cell in a first place. So this is a like a Keras like a official implementation that you will be able to find out. So it's from the official repository itself. If you will just look into the example, right, you're not supposed to go anywhere. Every kind of a code is already available in a Keras own repository, right? Just you have to search like a Keras GitHub repository. So from the official documentation itself, you will be able to get it and you will be able to build the model. Now if you will talk about a sequence to sequence, so people have given like a LSTM sequence to sequence and people have given LSTM like a sequence to sequence restore. So these are the different models that people have given to you. And again, so you can, if you're trying to understand like a sequence to sequence, so I think this is the best model. This is the best code, a core implementation of the code that you will be able to find out. In general, what happens is, so we try to call the entire library, we try to call the entire function, and then like we try to just pass the data. But this is the core implementation that you will be able to find out just based on the LSTM. Here in this section, right? So in this section, we are not doing anything. We are just trying to give a path of the data, right? So path of data means input text, English, Hindi. Let's suppose if I'm trying to make a translation. Now on top of that, so we are just trying to like read our data. It will be available in lines. We are just trying to iterate over the lines, right? And I'm just trying to give you a code walkthrough because you can take your time and you can try to understand it, right? So once it will try to iterate over the line, then we are trying to like extract all the characters one by one out of the entire data set, right? Then we are trying to like create the input character and target character, means input and output X and Y we are trying to create over here. And then like our tokens we are trying to create. And then here we are trying to define the length of the sequence, that whenever we are trying to give an input, what is the sequence. So someone has asked me a question that how we are going to define that, what will be the number of the input that we are going to give. You can control it over here. So you can try to define that what will be the length of the data that you are, or what is the sequence of the data that you are going to give as an input. Now here, so what we are trying to do, we are trying to do an enumeration. Enumeration simply means that, so for a particular character, it will try to generate a respective numeric values. So it will try to generate basically a dictionary for you. Key and value pair, it will try to generate. This is what we are like trying to do in this particular place, nothing else. So we are trying to create the encoder input data, then decoder input data, decoder target data we are trying to create, because here encoder will take one input and decoder will try to give you another output. We have to prepare all the data set. This is what we are trying to do over here. Now once this data preparation will be done, right, once this data preparation will be done, so here we are trying to create the model. So the architecture will start from here, from this particular place. Before that, we are just doing a data preparation, nothing else that we are trying to do. We are trying to create a basic like a LSTM over here. And again, now here, so you can try to say that we are trying to call a model.compile. We are trying to use optimizer as a root mean squared propagation. Then like a loss function wise, we are trying to use a categorical cost entropy loss, right? And we are just trying to define whether we want accuracy matrices or not. And then we are trying to call model.fit. Inside a model.fit, so we are trying to call encoder input data and decoder input data. as simple as that. So this is a single model that we are trying to create over here, and finally we will try to save it. Now in this particular place, right, in this particular place, so first of all you will have to create a entire encoder layer, and then you will have to create the entire like a decoder layer. Means model you will have to define, sample model you will have to define. So here you will be able to find out there is a function for our decoder sequences, and in this case, yeah, so it is going to return you the decoder, a final decoder output. So it's nothing but just a cell that we are like trying to define inside this one, that what this cell is supposed to give you as an output. So basically this is the core implementation. Whenever we try to implement this particular things in our use cases, right, it's not like you are supposed to write the entire code and then you will be able to use it. No, it's very simple. What you can do is you can just try to call LSTM sequence to sequence, right? Pass your data, your work is done. This is how easy it is. This is the core Keras implementation. This is the code which people have written from a Keras itself. So this is the like a code which people have released as an open source, so that you will be able to modify, and then on top of that, so you can try to perform any kind of a operation if you are looking for that kind of a control, right? If you have to modify like a layers inside that one, as you can see that people are using base model as a LSTM model over here. So people are using basically like a LSTM model in this particular place, right, in a decoder side as well as into a encoder side. In both the side people are using basic model as LSTM. Let's suppose I don't want to use LSTM. Let's suppose I wanted to use GRU, right? I can try to copy this code, and then I can try to convert this model. I can try to like replace this LSTM with a GRU. Accordingly, I can try to give an input which will be almost same, right? And then I can build my own architecture. If you are planning to build your own architecture, only in this case, if you are just trying to like train your data set, if you're just looking for the final model, in that case you're not supposed to worry about this entire set of a code. You can try to pick and choose a problem statement, and then simply you can call a Keras API, pass the data, train your model, and your work will be done. So this is how easy it is, or this is how easy it will be in terms of implementation, which I'll show you. It's just a first class, so I know like many people are confused, or many people will not be able to understand that how we can apply all of these code. But yes, implementation wise it's not at all tough. When I'll show you name entity recognition example in my class, you will be able to find out that yes, it is very easy. It's not as complex as these code, because these are the code which has been released by like a Keras itself, and so that you can try to like modify it, and then you can solve your purpose. Okay, so can you please send the link of the research paper? So not an issue. Chris will upload it in the same YouTube video itself. How it is better than a bidirectional LSTM? It's not better than bidirectional LSTM. Bidirectional LSTM is much better than this one. Can encoder decoder be used to find out the similarity between two things? Let's suppose a symptom such as nausea and a fever based on the disease they might have led to. It depends on the data set, what kind of a data that you have, right? Depends upon the data set. So yes, it will be able to find out. People, Dilip has asked these things many times, how to detect a name in text, right? That's the reason. So Dilip, don't worry. So like I'll be talking about a specific, I'll show you the example itself, a deployed example, end-to-end deployed example. I'll show you that is called as a name entity recognition, and I'll give you a end-to-end line by line walkthrough. This is basically like a Keras repository code. Will show you our code basically, that how we actually do our implementation, and you will be able to find out that it's not tough. It's very easy actually, and we can build this kind of a system. We can train our own model in this way. Yeah, Chris, any other question that we have to take?
No, I think that is sufficient for today's session. Anyhow, just forward me the links. I will be putting in the description.
Yeah, sure. So I'll just give you the link for each and everything that I have discussed, right? And probably in our next session, what I can do is like I will be talking about like a transformer based model. So I can jump into a transformer based model directly, right? where like we can try to show them examples, plus we can try to talk about the architecture and mathematics behind that in detail. Yeah,
Sure.
this
So it will
was
be
like
on
a,
Wednesday, right?
yeah, Wednesday same time.
Wednesday, same time.
Yeah,
Okay.
same time
8
Wednesday.
o'clock, guys. Okay, guys. So if you like this video, please do hit like for Sudhanshu. He has taken out his time and he has come over here to explain these things. Thank you again, Sudhanshu, for this
Yeah,
amazing
thank
session.
you.
So, guys, this whole video will be available in deep learning playlist itself. You can actually refer any night, anytime, whenever you require. Anything from your end, Sudhanshu? You want to tell?
No, I think it's fine. Just try to go through it, and people can just try to like revise the basic fundamentals of this RNN, LSTM, GRU, right, and encoder decoder, so that it will help them to understand transformers. Otherwise, it will be difficult for sure.
Okay, guys. So just before coming to the next session, which is on Thursday, sorry, Wednesday, please make sure that you complete the whole complete deep learning playlist in my YouTube channel. Make sure that you complete completely. It will be completed till here. That will be the main thing that will be required for Transformers and Bert.
Many people are asking about our community classes, so I think tomorrow is a big day. So we are going to make announcement tomorrow.
Yes, tomorrow we are going to make the announcement for community classes. All the details will be explained to you in a live session.
Yes,
Yeah.
yeah.
Okay, Sudhanshu, so thank you for this amazing session, and thank you guys for seeing it. We'll meet you on tomorrow live session telling about the community classes.
Okay,
Thank you, everyone.
people are asking about like Chris, have you made a videos on GRU? So have you done that?
Mm, I think
GRU, LSTM, I know LSTM is there. I know that.
Okay, no problem. I'll make a video on GRU tomorrow morning itself. Okay.
Okay, sure.
Yeah. Cool then. Okay, guys. So thank you all for this amazing session. Thank you, Sudhanshu, for this amazing session.
Yeah,
We'll see you all on Thursday. Okay.
yeah.
Bye
Thank you
bye.
so much.
Have a
Thanks,
good one.
Chris, and see you again. Yeah,
Yes.